Yeah. All right, so we're going to do exponential functions. We're going to review today all about exponents and their functions and stuff like that. And then tomorrow, I believe we're going to do the derivatives. Aren't you excited? Or are we no, we might do logs. I take it back. I think we do logs. I got to do all the logs. And then we'll do all the derivatives with that. Woo, woo. Yes. All right, so exponential functions. Just again, you should have been doing this since Algebra 1 days, but let me go over it with you. An exponential function is written in the form like this. F of x equals a to the x, some base to the x power. Your variable is your exponent. That is an exponential function. Your variable is the exponent. It's still hard to see. I'm trying to help Jack out. All right, we are going to go over all the properties real quick. And I do want you to write them down because it helps you remember. Properties of exponents. If you don't remember these, Lord help you. First property, any base to a 0 power, what is your answer always? 1. Do not tell me 0, ever. Next property, two bases with two different exponents. If the bases are alike, what do you do to the exponents? Add them. Keep one base, add the exponent. Do not tell me if this was like 2 to the 3 times 2 to the 4. Oh, it's 4 to the 6. It drives me insane. Keep one base, add the exponents. What if you're dividing? What do you do to the exponents? Subtract. Keep one base, subtract top from bottom. Top from bottom. Okay? Property 4. If you have a base going to an exponent and then you raise it to another exponent, my teacher called it power to power rule. What do you do with those two powers? Multiply them.
What does the variable is with the green?
The exponent.
What? I didn't do anything wrong. I actually didn't do anything wrong.
Okay, but we're actually on property number 5.
I just couldn't see it.
What do I do if I'm multiplying two different bases, but I raise them both to a same power? What do I do with that power? What am I allowed to do? I'm allowed to put it each of them. Listen, you cannot do this rule, which is what all of you think if there was a plus sign here. That is not allowed. You can't be like, if it was 2 plus 3 quantity squared, whatever, you cannot be like, oh, 2 squared plus 3. That's not true. 2, you always have to inside first. So that's why if you have a plus inside here, you would actually have to FOIL. Number 6, if you have a fraction being raised to the power, same thing applies. A to the x over b to the x. Number 7, good old negative exponents. What do they mean? Elevator pass, exactly. You move that down. If the negative is in the bottom, though, you move it to the top. Negative on top, move it to the bottom. Negative on bottom, move it to the top. And the last one, a to the fractional power, xy. Do you know what that means?
Like your square root.
It's roots, not just square roots, but roots, yes. Your denominator is the index, and then the top number is the power of that base. But please don't just write it this way. It actually can be written this way. It would be the y, I don't even know if that's the word, the y root of a to the, and then you could put the x on the outside of it also, which I will show you today how that works. Okay, so let's do some examples real quick. Your homework tonight will say simplify. You need to find exact values, and you are not allowed a calculator. So do your best tonight to not use your calculator. If you get something like, 5 to the 5th power, just leave it 5 to the 5th. You don't have to actually multiply it all the way out, okay? I'm not going to be mean like that. So let me actually write down a few of them right here. 2 squared, and there's so many I can write, y'all, but I just tried to limit it to something to refresh your brain here. 9 to the 2/3. Let me do one more here, and then I got 5, 6, and 7. I'll do it in a minute. All right, so let's try to do some of these together. These are pretty easy. We can do it without a calculator. So what would you do? And there's different ways of doing this, by the way, FYI. What would you do to this one? That's exactly what I would do. Like some people are like, do you move this to the bottom and then do it? That's fine, but I just add them. I keep the base. I add the exponents, which would be to the -1. And what is 2 to the -1? 1/2. Okay. That's how I would do it. Again, multiple ways of doing this. I'm just showing you how mine. What is 4 to the 3/2 without a calculator? What is that the same as saying? The what? It would be, again, square root of 4. So the square root of 4, and then I would raise that to a third because you can take the square root of 4. What is the square root of 4? What is 2 to the 3rd? Excuse me. Excuse me. 3. Okay, when you get this tonight, these are like bases, yes. 9 is not. However, could you not make 9 into a like base? 9 is the same as saying what? 3 squared. So if I rewrote this as 3 squared and then raised it to its 2/3, right? 3 squared to the 2/3 is actually 3 to the 4/3. Then I times that by 3 to the 1. Really, that's a 1. Then I times that by 3 to the 2/3. Oh, now they're all like bases. So if they're all like bases, I keep one base and I just add these exponents. What is 4/3 and 2/3 make? 6/3 is what though? 2, and then 2 and 1 make 3 to the 3. Or you could do that one, 27. Without a calculator. All right, let's do one more.
Let's go.
Here, 1/3 to the -2. I think I love that you guys know elevator paths and etc., but I think you don't know this. A negative exponent is actually a reciprocal is what you need to do. If you have a negative exponent, you can flip what's inside and change that to positive. So actually, that's what I would do. I would say 1/3, instead I'd say 3/1 to now the +2. Those are the same thing. And then what is 3 squared? There's your answer. Done. Okay?
Yeah.
Yeah. Let me do 3 more real quick with you here. Again, I'm trying to give you a lot of different ones. You'll be doing some similar here. Here comes the rain. Here we go. 3 squared over 9 to the 3rd. 3 squared over 9 to the 3rd. Again, on tonight's homework, you got to come back to me doing this. If you see bases that you can make them all into the same base, make them all into the same base. Because we're doing that. We're going to get into logs and natural logs and all that. So this is 3 squared. This 9 is also 3 squared, but raised to the power of 3. So what would that bottom become? 3 to the 6. So if you have 3 squared over 3 to the 6, that's 3 to the 4th on the bottom. And if you didn't know what 3 to the 4th is, that's fine. But you should know what 3 to the 4th is. 3 squared is 9. Another 3 squared is 9. 9 times 9 is, that's the answer, 1/81. I would have let you keep it like that if you didn't know. All right, are you allowed to multiply these together? These are unlike bases.
You have to do it to 9 over the.
I know you'd be like, no, Mrs. Seta, I can't do anything here. Well, watch this one, yeah. Because I would in the same way until I rewrote these. 2 to the 1/2 is actually square root 2. 3 to the 1/2 is actually square root 3. Are you allowed to multiply like radicals? You are. You're allowed to multiply what's underneath. So that's actually root 6, or 6 to the 1/2.
What are you all laughing at over there?
All right, and then last one here. There again, several different ways to do this. I'm showing some of you would have been like, can I keep the like base and add those? You sure can. But I don't know off the top of my head what -2 and 1/4 is. I do, but I'm not. Pretend I don't. Okay. So what I would do is I would distribute this 4. Since this is multiplication, I would just multiply those powers to 4. So this would actually be 8 to the -8, right? And what's 1/4 of 4? 1. So times 8 to the 1. See, that's way easier. So what would that be? 8 to the -7. Don't leave it like that. Rewrite it as 1 over 8 to the 7. I know what 8 to the 7 is, so I'm leaving it like that. How do you feel about this so far? All right. Just a few more things we're going to solve, and then we're going to graph without the calculator, and we are done for today. This is all like kindergarten. Kindergarten, people. Kindergarten. Solve equations for x. To the x, 64. Can you read this? This is number 1, 2. There's another one. I'll give this to you in a minute, though. All right, here's the thing about tonight's homework. If your x's are in the exponent, then you need to make these two things like bases. If this is a 2, make that into a 2. If this is a 3, make that into a 3. Make them into like bases. So let me write that down. Change to like bases. Again, you have no calculator for this, so you need to do as much of this as you can without a calculator. Okay. So 64 is really 2 to the 6. How did I know that? Well, I know 64 is 8 squared. I know that 8 is 2 to the 3rd, so 2 to the 3rd squared, 2 to the 6. So then I think it's easy to tell you what x is right now. What's x? 6. Once you get these to be like bases, you can ignore that and set the exponents equal to each other. X equals 6. All right, let's do the same with this one. 81 can be written as a power of 3. And 1/3 can be written as a power of 3. Everybody forgets that. This is actually 3 to the what? -1 to the x minus 3. 81 is 3 to the 4th. We just saw that on the other side. Power to power, multiply. So this would be 3 to the -x plus 3. And this would be 3 to the 4th. And again, set these two equal. Once they're like bases, your exponents are equal. So what would that be then? -1. Good try though. -x equals 1, x equals -1. All right, this one is also interesting because a lot of people, now notice your x is not the exponent, right? But the exponents are the same. If you have an equation and this whole side is being squared and this whole side is being squared, yes, then couldn't you safely assume that this must be equal to this? So 5 equals 2x plus 3. What does x equal? 1. You're allowed to do that. If one whole side is being raised to the same power as the other side, then those two bases are the same.
Got it.
All right, and then last one, because a lot of you probably forgot this from last year in Algebra 2 and stuff like that. If you have a base that you're raising to a fractional power and that base is the x, do you know how to undo that fractional power? How?
Logs.
Stop.
We are going to get there, but no.
Don't you do that like the
Yes.
Yeah, really? You did like x to 64 equals 2/3?
Oh.
No. Actually.
So close. Okay. If it was, here, how about this? If it was x squared, what would you do to undo a squared? Square root. What is square root as a fractional power? 1/2. How do you undo 2/3 then? Raise it to 3/2. I know, I'm sorry, honey.
Reciprocal.
And the reason that works is because all of these would cancel to x to the power of 1, which is what we're solving for. We're solving for x. We're solving for x to the 1. So this is the 64 to the 3/2 or the square root of 64 cubed. Well, we know what the square root of 64 is. What's the square root of 64? 8 cubed. I don't really know what that is. I think it's in the 500s. 64 times 8. 502? That doesn't make sense. It's
Wrong.
500 and something. But we'll go with, just leave it 8 cubed. We're good. All right, last but not least, and then we are done. I told you this was all, what was it? 512 was right, yeah.
Oh, there we go.
I was going to say, it's not. Sketch exponential graphs. Yay. Let me give you 2 of them and we are done.
Boom, we're done. We're done.
F of x equals 2 to the x. You know, I say that to you because I feel like it's like the workout when she tells me, she's like, we only have 1 more round left. I'm like, yes,
I
yes.
like how you do that.
Autumn Calabrese. We only have 2 more left. We're 2. I can do 2. I can get it done in the next 3 minutes.
Yeah, like a workout. I mean, you have had many athletic injuries.
Obviously, I am.
Many.
Look at how athletic I am right now. Why are there so many smiles right now and laughter in your hair? I can't believe it.
Yeah, stop.
Yeah, really. Okay. All right. I would say you all know that these exponentials go up really fast. So they start really slow. Their asymptote is near 0, and then they go up really quickly. I would like you to make a graph. Please try as much as you can. If you have your calculator and use this, that's okay. But try to give me some points. I would say give me like -1, -2, 0, 1, 2. And then we'll graph that. So here's what I mean. Let's actually do it backwards this way. What is 2 squared? What is 2 to the 2? 4. What is 2 to the 1? What is 2 to the 0? So what would 2 to the -1 be? 1/2. It's the reciprocal of that guy. What's 2 to the -2? 1/4. It's the reciprocal. So when you go to graph these, it's very tiny. And then here's 1. And then 1, 2. And then look what happens at 2. You're already up to 4. I mean, these are growing quick. They're exponential. So they go very fast. Okay? Let's do the same with this one. I'm going to stick with -2, -1, 0, 1, 2. I think that looks pretty good. And I'm actually going to work this way down because -2 times -2 is +4, right? So 5 to the 4th is 5 squared squared. So 5 squared is 25. 25 squared is 625. I know. That's one I know. -2 times -1 is 2. What's 5 squared then? 25. 5 to the 0 is 1. 5 to the -2 would be the reciprocal, -1 would be the reciprocal of 25, so that's 1/25, and this is 5 to the -4th, which would be the reciprocal 1 over, that's very tiny, 1 over 625. So this one actually goes this way, 0, 1, it goes very tiny here, very tinier here, and then at 1, -1, I'm all the way up to 25. Whew. This is very
exponential.
Yeah, very, 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 very. But notice it's the flip of this one. Why is that? What's flipping it? Do you remember? The negative exponent. Okay. All right, that's it. See, this isn't that bad. This is like kindergarten stuff for you people. Page 262, number 2 to 34 even. Okay, and then and you got to do that in. Let me stop this.